Similar figures. Remember, similar figures have the same shape, but not necessarily the same size. The symbol for similar is that sleeping S. If two figures are congruent, they are automatically similar, but not the other way around. There's a convenient theorem for similarity of triangles. If you could show that two angles of one triangle are congruent to two angles of the other triangle, that's enough to conclude that two triangles are similar, and they're similar by the AA theorem. If the AA requirement is met, then we could say that two triangles are similar, and now we can set up a proportion relating the matching sides. So let's practice. Show that triangle ABC is similar to triangle EDC, and then solve for X. So notice you first have to demonstrate they're similar, and then you can use a proportion, because if they're not similar and you use a proportion, you're going to get incorrect results. So we need to demonstrate these two triangles are similar. All we have to do is show that two pairs of angles, here's one pair, are equal. And you say, well, where's the other pair of angles? Well, the ones that are right here. Anytime you have two lines of segments crossing, these angles that are formed are congruent. They're called vertical angles. So A, A, make sure AA is in place. By AA, the two triangles are similar in this case. Now that we know that they're similar, I break them up into two triangles so I could visually see them easily. It's easier to see them like this, separated. Now you could set up a proportion. 5 is to 12 minus x as 8 is to x. This is one way you could set up the proportion. This over this equals this over this. You could have also said this over this equals this over this, and you get the same answer. Now you cross multiply. So x times 5 is 5x. 8 times 12 minus x is 8 times 12 minus x. Distribute here. This is a 96, 8 times 12. And 8 times x is 8x. Get the x's together. So I'm going to move this 8x to the other side by adding. It cancels from here. Collect these and combine them. That gives you 13x equals 96. And then just divide both sides by a 13. So x equals 96 over 13 units. Here's another use for similar triangles. Suppose you wanted to know the height of this tree, but you don't want to climb up with a measuring tape. So all you have to do is take the shadow. Notice here's the sun, and it's creating a shadow of the tree. There's a shadow. There's a shadow. This shadow here is all of this. And this little one is just the meter stick. You put a meter stick, it creates a shadow. This shadow is the shadow of the whole tree. Now break them up into two triangles. Notice this passes the AA test. Here's the angle that they have in common. And then both of them have a 90. So it's A, A. So break them up into two triangles. And now you could set up your proportion. X over 40 equals 1 over 2.5. Cross multiply and solve. So cross multiply 2.5 times x and 40 times 1. Isolate the x. Divide both sides by 2.5. So it's 40 divided by 2.5. So without climbing the tree, you could find out that the height of the tree is 16 meters.